Now, it's in Latin, so you say it backwards. Mathematical Principles of Natural Philosophy. Remember, natural philosophy is what science was called 2,000 years ago. Its author, Isaac Newton, at Trinity College, Cambridge. He is the Lucasian Professor of Mathematics, the chair Stephen Hawking was recently sitting in, and a member of the Royal Society. So, printed in 1686, this one little book changes the world. You open it up and there's a quick preface about why he wrote it, but then you get to the very first page, and on page 1 you see the 3 laws. Every body preserves its state of rest or uniform motion in a right line unless compelled to change that state by forces impressed thereon. The law of inertia. The second, the alteration of motion is ever proportional to the motive force impressed, or forces change motion. The second law. And the third law, to every action there is always opposed an equal reaction. These are Newton's 3 laws of motion and everything that our course is founded upon. So today we're going to outline a brief biography of Isaac Newton, state the 3 laws of motion, and apply the most powerful equation in all of physics, Newton's second law.
Okay, so those learning targets up there, we'll just spend a few minutes on the history of Isaac Newton, or where he came from, what he did, where he went to college. The main part is stating the 3 laws of motion and then using F equals m times a to solve problems. Now, what we did is we cut down the amount of problems, where I think you only have 5 problems today. The lecture will be over in about 10 minutes, so that would give you about 25 minutes or so to do those 5 problems. You can do them directly on the digital document, or again, if you like to print it, you can do that. But I think it's easy enough with only 5 problems to do it on the digital document.
The motion problems. Yes, it's time for this guy. Not a bad looking guy. Yeah, that's his own hair. Back in an era of wigs, he just went with his hair. And why not? He has hair. But let's look at Newton's laws of motion. Sir Isaac Newton is born in 1643 and he will pass in 1727. He will survive the English Civil Wars, the decapitating of a king, the Cromwell Protectorate. Cromwell dies, another small civil war, and the restoration of the king. He's born on a farm in northern England, the region called Northumbria. And while he's young, his father dies. Now, at this time, women could not inherit land. So mom, in order to preserve the farm, does the only thing she can. She marries the widower next door. And this guy and Isaac will fight continuously for the rest of their lives. Isaac attends Cambridge University. And at Cambridge University, he is without a doubt the top science and math student in the school. Nobody is close. But he has a problem. He's a real jerk.
All right, you guys getting that? That's not going too fast for you? Someone say something.
No, we're good.
Okay, thanks, Langlois. Okay, so yeah, if it looks like it's going too fast, but it sounds like while he's talking, it's giving you guys time to write also. So I'll keep playing.
Oh, he is smart and he knows it, and he lords that over everybody who's lording their positions over him. When he graduates, he expects to be made a professor at Cambridge, but, well, nobody can much stand him, so they send him home just in time for the Black Plague. Again? Once again, the Black Plague plays a role in our story. Well, all the people who could get out of London did get out of London. The rich and the wealthy retired to their country estates. The people left dying in London are left to fight the rats and the disease. Eventually, the disease subsides, and Newton is called back to Cambridge to teach. While he's there, he invents calculus. He starts the calculus using that to come up with our course, physics, and writes the first physics textbook. The prince.
Okay, so this is the bottom slide on page 1. Once you're done filling that in, flip it, and I'll start playing again.
Principia. Earlier, we'd talked about what forces are, and we'd said a force is any push or pull. Today, we'll know how much of push or pull. Well, there are two kinds of forces. There are contact forces and long-range forces. Contact forces are any forces that act upon an object by touch, whereas long-range.
Okay, by now you guys know too the setup of the quizzes. So you know that the multiple choice part of the quiz and test are taken directly from the PowerPoints here. So, and usually the review guide also is in order of the definitions here on the PowerPoint. So when we look at forces, any push or pull, and then we'll talk about contact forces and the long range forces coming up next.
Contact forces are any forces that act upon an object by touch, whereas long-range forces have no contact required. They are generated by a field, a four-dimensional hunk of space-time surrounding the object. Now, when we diagram objects using forces, we have two kinds of diagrams. So far, we've been using vector diagrams. But once we will start using for this is a body of diagrams called free body diagrams. These are vector diagrams showing all forces acting upon an object drawn through the center of mass. Well, here, let's take a simple basketball. Let's hold a basketball up in the air. Well, here's a picture of me holding up a basketball. Well, of course, that isn't me. That is the Arnold Schwarzenegger, in the middle of his 8 Mr. Olympia titles as the world's most perfectly developed man. Well, to hold that basketball up, it's being pulled down by the weight, the interaction of the object's mass and the acceleration of gravity. In order to hold it up, Arnold has to have an applied force. Well, here, let's get rid of Arnold and look at the problem again. There is a force pulling the object down. The force
you can label this. This is the top slide
that interaction
on page 3.
between gravity and the object's
label
mass.
this in there.
The weight, F sub G. Everybody say F sub G. Whereas in order to hold it up, I have to apply a force. This is known as the applied force. And
so again, on the top of page 3 with the basketball, labeled those F sub G and F sub app for the applied force and the force of gravity pulling down on the basketball.
it is the interaction of these two, the weight and the applied force, that tells you what happens to the object. See, we're concerned in not just one force, but all the forces, and that's referred to as the net force acting on an object, F sub net. Net force, which means the resultant force produced by the addition of two or more forces acting on an object.
Eventually, we'll get to net forces where you add them up, either two forces pushing in the same direction or forces going in opposite direction that could cancel each other out. For today, for the problems, we will just use, again, F equals M times A where we find the force by multiplying mass times acceleration.
Let's take another look at, well, this is me working out in the gym. No, that isn't, of course. That's Dr. Franco Columbu, Arnold Schwarzenegger's chief competitor and his best friend. But let's look at this. This is a deadlift with 1, 2, 3, 4, 5, 6, 7 plates on each side. So that's 7 plates here, 7 plates there at 45 pounds each. That's 630 pounds. The bar itself is another 45. And if you'll look, there's a pair of dimes, a pair of nickels, and the collars. That is a 700-pound deadlift. Walk over, pick up 700 pounds. Well, in order for that to happen, you have to overcome the weight, which is pulling that towards the center of the earth. So you apply a force to pick it up. How fast it moves, how far it moves, and the speed at the end is all determined by Newton's laws of motion. Newton's 3 laws of motion. They are known by a separate name for each law. They are known as the first, second, and third laws.
Once you fill that in, flip to page 4. So this is the bottom of page 3. We'll be going to the top of page 4.
The first law of motion was originally stated by Galileo, but put in its final form by Sir Isaac Newton, the definition of inertia. An object in a state of uniform motion or at rest remains in uniform motion or at rest unless acted upon by an outside force.
With the inertia here, that first law, just know inertia, a simple way to describe inertia is the object continues to do what it's already doing. So if it's just sitting there, it will continue to sit there unless acted on upon by another force. If it's already in motion, it will continue in motion until something else either speeds it up or slows it down, usually friction. And you can give me a thumbs up emoji when you're done filling out these longer ones so I know to go on. If I get like 5 or 6 thumbs up emojis, then I'll move on to the next one. So I have the, like that right there. Langlois, am I going at a good pace?
Yeah, but I don't think we have the emojis.
Oh, okay.
We have like raise hand and that's it.
Okay, I'll send you a link to load the emojis later on. Okay, so I can go to the next slide?
Yeah.
Okay, here we go.
So whatever an object's doing, it's going to keep doing it unless something pushes on it. If it's moving, it will keep moving unless a braking force is attached. Or if it's not moving, it will stay motionless unless a force is applied. You kick it or step on the accelerator. The second law is the definition and the mathematics behind a force. A force is the product of an object's mass and any resultant accelerations. Or mathematically, the deceptively simple looking equation F equals ma.
All right, with this right here, with Newton's second law, the definition is multiplying the mass times the acceleration. But I do just want to talk about real quickly, and again, you guys are, most of you are in the higher level math class. I think it's algebra 2. So when you're solving, because the first couple problems you'll solve just for force, which is just finding the givens for mass and the givens for acceleration and multiplying them. But if it asked you to solve for M or A, remember to do the opposite of what's already happening. So if you're going to solve for M, you want to get M alone. Right now, A is multiplying times M. So to do the opposite, you would divide each side by A. So the formula for mass would be M equals F divided by A. And then likewise, the formula for acceleration, you would divide each side by M. So acceleration would equal F divided by M. So just that basic algebra of doing the opposite of what it's already doing to get the variable that you want to solve for alone.
At the start, it really is that simple. Take the mass times the acceleration, and you have the force. Oh, but wait a minute. Let's remember just what an acceleration is. Oh, no. And then consider the remaining kinematics equations. Uh-oh. Well,
so listen, don't get too discouraged yet with what he's talking about later on with the kinematics. Eventually, you may have to solve for acceleration using VF minus V naught over T. And don't forget the acceleration due to gravity that we've already used, which is 9.8 meters per second squared. So those are things that we can work through, but for the most part, I think you guys will get it.
Well, that's where we're headed by the end of the unit. The third law says that laws come in pairs, equal and opposite. For every force applied to an object, there exists an equal and oppositely directed force, or forces come in pairs.
Once you write down this slide, we'll go to the top of page 5, and it's the example practice problems. So you can actually practice those on your own, and I'll play the video, but just determine what you're solving for. You can underline on this. It doesn't, or you can write them on the lines, but the givens you can either underline or circle or write them on the lines to the right, and you will need a calculator. So obviously you can use your cell phone at home for a calculator.
You quite often find this when somebody is surprised to discover that if they get mad and punch a wall, that the wall punches back. As hard as they hit the wall and apply a force to the wall, that wall applies the same force to their hand, shattering their hand. So the learning targets and what's on tap for today. Well, we've looked at Isaac Newton. We've looked at the laws of motion. Let's take a look at applying the second law. Well, you know me. Whenever I have a physics problem, what's the first thing I have to do? That's right, read it. The force is required to accelerate a 1,200 kilogram car with an acceleration of 7.5 meters per second squared.
Okay, so take that problem right there. Your givens are 1,200 kilograms. That's your mass M. Your acceleration is 7.5 meters per second squared, A. You are solving for F. So on that blank slide in the middle of page 5, just write down F equals M times A and use a calculator to solve. And then I'll show the answer in a minute. And buzz in or turn your mic on if you have questions about, again, the setup. But for this first one, it's just F equals M times A. And then you're multiplying mass times acceleration. Now remember from the reading guide that the units for force are newtons. A kilogram times meter per second squared equals a newton. And that's a capital N, as in Nikki, that you'll use for that. And don't ask me where I came up with Nikki. I couldn't think of another word right away that started with N and didn't sound like M.
Where? I've read it. After I read it, the next thing I always do is, absolutely. Our car with a mass of 1,200 kilograms is accelerated at 7.5 meters per second squared. How much force does that? Read it, diagrammed it. After I diagram it, I list. Correct. I know that the mass is 1,200 kilograms and the acceleration is 7.5 meters per second squared. I need to find the force. Well, the deceptively simple Newton's second law equation says F equals ma. Do I have to do any algebra? Well, not yet. Good. It's always a good day when I don't have to do algebra. So lastly, grab your calculators, go. What force was applied to that car to get it to accelerate? 9 kilonewtons, 9,000 newtons, which is a lot of force.
You guys good with that? Logan, how'd you do on that? Good?
Yep.
All right, good. Okay, go ahead and do that second problem. That one you're solving for acceleration. As you're working on it, I'm just going to play the video. You should be done with it by then. Remember, to solve for acceleration, divide each side by m. So it'll be F divided by m. So do that last problem, and then I'll show you the actual problem work that I'll grade.
Let's take a look at a second. Whenever I have a physics problem, first thing I have to do is a force of 2,525 newtons is applied to a car with a mass of 475 kilograms. Determine the acceleration experienced by the object. Read it. After I read it, the next thing I do is, and there comes the car of science racing through our problem. A force of 2.525 kilonewtons is applied to an object with a mass of 475 kilograms. What's the acceleration? Read it, diagrammed it. After I diagram it, I list the force of 2.525 kilonewtons, the mass of 475 kilograms. What's the acceleration? Well, we're working with the deceptively simple Newton's second law. So my equation is, but I need to solve for acceleration. And accelerations is over here on the wrong side. So I have to get mass from one side to the other. So what do? Add, subtract, multiply, or divide? Correct. Divide by the mass, and I end up with the acceleration is the force divided by the mass. Plug and chug. What do you get? And correct, 5.32 meters per second squared. Newton's second law, deceptively simple, and yet by the time we're done next semester, they will yield the hardest problems of this entire course.
Okay, so listen, remember when you're doing the problems, my chair keeps dropping down. Remember when you're doing the problems, today your givens are F, M, and A. So that's all you're looking for today is F, M, and A for your givens. And this is actually shared in, the Google Classroom for you under the assignments, or it might be under, no, it's under assignments turn in. So this is the worksheet. There's a learning target question at the beginning. So if you feel like the learning targets were good, the outline of Isaac Newton, learning the 3 laws of motion, and then also learning or applying how to solve problems using the formula. Just say agree, partially agree, or disagree. But I thought the PowerPoint unit lesson was pretty good. And then here's the problems here. Okay, so there's 6 problems to do. And remember, you can copy and paste the formula from the top. So this first one I'll show you, determine the force. So I'm going to find this for force, copy, and then the equation, paste, and there's your equation in there. The givens, you can just copy and paste right from the problem. Here's your mass, here's your acceleration, and then type the answer once you get it on your calculator. 6 problems. I will stay on the Google Meet. Don't get off yet. I'm going to stop recording in a minute.